the cloud. Ooh, yeah. Okay. Whoever just came in, oh my God. This should be a link to the workbook we're going to be using. And this one should be a link to the sign-in sheet. You guys feel free to chat away. I'll try to catch up every now and again if you have any questions, or just speak up if you have a question. Okay. So very first thing we need to talk about, and also let me know if you guys can see okay what I'm writing up here online. Let's start off really nice and basic. Be there. Yeah, beautiful, right? Because all exponents are keeping track of how many things we have to multiply. So mathematicians are very lazy or frugal with their time, depending on how you feel about them. And we said, why would I write 5x's when I could just kind of write shorthand for it? So most mathematics is shorthand that we all have to catch up with. It was decided on centuries before we graced the earth with presence, right? So we have to kind of catch up with what these old people did back in the past. That's pretty straightforward, hopefully. What about this here? Is everybody doing okay out there? Beautiful, right? Yeah, because you would have 8 x's up top, 5 down below, so 5 cancel, and you got 3 left. Okay, I love it.
Wait, I'm so sorry. On the first one, is that x 2 plus x3, or was that times?
Times.
And then it's 5 because
you
you added the 3 and the 2.
Oh crap! Did you die? Everybody, hold on. Yeah. Oh my God, I love it. Let's see what I can do here. Let's see if I can do it from here. Oh man, that's even worse.
Oh no, it looks fine.
No, hold on. Everything is better when you do it 2 ways. Okay, let's see. Let's see what I can do here. So just a bit. Okay, how's that?
It's good.
It's good. I like that. It's good. Maybe it's Red's fault. Let's see. Which one of you guys is going to work? Anybody know what? Crap. No, not green. Anybody know what? There we go. That would be. No. Oh, okay, sure. So a negative power means flip.
Right.
And let's see why. Let's kind of investigate this. What could I set up considering this? What could you set up? So if I put like an x to the third up here, what would I put in the bottom so that the answer is this, considering what we do? No, don't. So I want a number here so that this becomes this.
Oh.
And again, what do I do with the powers when I'm dividing? Subtract. So what do I subtract from 3 to get -1?
4.
4. Kick ass. I subtract 1 more than 3 because then I'm like in debt, right? Try to take $4 from me and all I have is 3. I'm in debt by 1. Yes. But watch this. Stay with me. Isn't this x times x times x over x times x times x times x? Yes. 3 x's over 4 x's. How many cancel? How many's left? Where? Bottom. So all a negative power means is flip. That's all it means. Negative power means flip. Negative power means flip. That's all it means. That's good. And we just sort of proved it there, right? So if I see sitting somewhere, so for example, if I see this 10 to the -7, what's an immediate way I can rewrite that? Yeah? No. 1/10 to the If it was negative, it would never stop. It would keep going up and down, up and down, up and down. It's not, it doesn't like it up here, does it? So it's gonna move down and now it's happening.
Oh, so it just turns positive.
Yep.
Every time it flips.
Why? Because the negative did its job. Why would it still be there? Right? I used to have students that would tell me the square root of 9 equals the square root of 3. You guys see the issue? What is the square root of 9? It's just 3, right? And I'm like, why would the square root still be there? It did its job. Same thing here. Why would the negative still be there? What's its job? Flip it. So of course it's gone once you flip it. How you guys feel?
Good.
Okay, real quick, I really want you to buy into this. Not just buy into it, but realize that it's true. That's a better way to say that, Jeff. Watch this. Blue, you suck. Let me see. Red, so I'm gonna have to go with red. Watch this. What would this be? X to the 8th times x to the negative 2. Because remember, what do we do with powers when we're multiplying like bases? We add them. So what is 8 plus negative 2? 6, right? You guys with me? And what is x to the 8th divided by x squared? What do you do with those? Subtract. So what would that be? Same freaking thing. So what x to the negative 2 must be the same thing as 1 over x squared because it leads to the same answer. In fact, it makes sense. I have 8, I'm losing 2. I have 8, I'm losing 2. That's what they both mean. That's why that notation means the same thing. Okay. We just came in. Eventually, you guys need to sign and sheet it. Still out there somewhere? Did I get it? Sign it real quick. Oh, I guess so. All right. You guys okay out there? It's probably not the best view of the board. A little bit. Yeah, that's good, Jeff. Oh crap. Let's not look at the floor. Let's not look at the floor, Jeff. There we go. How's that? A little better? Okay.
Yeah.
Everybody on Zoom is like, I've just accepted how things will be for me. Okay. So negative powers only mean flip. Oh my gosh. Okay. We spared every expense when it came to erasers. Okay. Wow. This is an eraser. So watch this. What would this be? 1 over b to the negative 2. What do you think?
B to the negative 2.
Say again?
B to the negative 2.
No.
B to the negative 1.
That's it. So how many b's want to flip? 2. So they flip and they're done. If it's on the bottom, it flips up top. If it's on the top, it flips to the bottom, right? So I always like, you know, it seems very silly. It says it don't like it down. So of course it likes it down. Right? Like a bunk bed. I don't want to be down there. Yay. It wants to be up top. Right? Somehow this is going to relate to scientific. Did everybody get that sign in? Okay. Somehow this is going to relate to scientific notation. In fact, we got one more exponent to talk about, and then we'll do some scientific notation. What in the world would this be?
One.
We got some people saying 1.
X.
And somebody saying X. What is this? By the way, what is just an X sitting here by itself mean? What's understood to be here? And 0 doesn't equal 1, so that can't be what it is. So we're like, what the shit, Jeff? All right, so remember how we figured out x to a negative power. So if I put x cubed up top, what would I put down here? So the answer is 0 here. Considering what we do when we divide. What do we do when we divide like bases?
3.
subtract. So to make 0, like you said online there, you have to have a 3, right? Is that cool? What is something divided by itself? So those of you who said 1, you're right. Kick ass. You guys okay out there? So I really want this to make sense. Can somebody tell me how many x's are in that expression right there? How many x's are there? 2. You with me?
2.
How many x's are here? 1. How
1.
many x's are there?
0.
None. There you go. No x's there, right? So that's really 7 times 1. There's no x's. That's all x to the 0 means, is no x's. So there's just that understood 1 that's in front. That's the only thing there is. How you guys doing? Okay. Let me know the minute. So I like to say this all the time. If I'm going too fast, slow me down. If I'm going too slow, deal with it. Right. So, right. Just okay. So, and again, you guys online, if you want to throw something in chat, if you have a question or just speak up. Oh, good. Okay. So let's try this. Let's do some actual science stuff, some scientific notation. So here's the idea behind scientific notation. If I have a number like this, right? And this could be trying to describe the United States debt or something, I don't know, right? Or the distance between 2 stars in miles, right? You guys with me? I mean, so this is going to come up in a lot of courses. It took me a while to freaking write that, yes?
Yeah.
So again, math people, lazy or frugal with their time, we're like, oh, why would we write all those stupid zeros? There's got to be a better way to communicate to somebody how many decimals there are in this big ass number, so I don't have to write all those freaking zeros, right? So let's do this. Let's start with a smaller example. 4,000. How do you rewrite 4,000? It's 4 times 1,000, right? And then what is 1,000 made of?
10 to the 3rd power.
How many tens? 3. That's scientific notation. Right? So it's not even notation. It's just a little problem that works back out to the number. You guys am I with me? And this is the one place we still use an x to mean multiplication. Right? In algebra, we're like x means whatever. We can't use multiplication, but this is the one place. It's just a part of the notation. Kick ass. So what's the shortcut here? Where's the decimal? There. How many places do I have to move it so there's 1 digit in front of it? 1, 2, 3. 3. Every time I multiply by 10, it moves the decimal over 1. So if I move the decimal back 3, it needs to multiply by 3 tens to become back what it used to be. So a positive power makes a big ass number because I'm actually multiplying by 10 over and over and over again. That makes sense. I was really bad, and I still am actually, with left and right. I have to do this when I'm driving. Somebody says turn left, that makes an L. So I'm like, oh good. I'm fine admitting that. I got too much other stuff in my head. So I'm fine with that. So when I was taught this, they taught me left and right. To me, it makes so much more sense to think big, small, right? Positive power, big number, positive power. Right? So if I have this, now how do I write this? Can somebody tell me how to write this not in decimal form? Can somebody just read this to me? Don't say 0.004. I want the official mathematical way to say this number. What place is this in?
-2.
I'm sorry?
-2. It'll be like, it'll be 4 times.
Oh, I
10
see. You're trying to
the
get to here.
negative.
I'm not there yet. I'm sorry. So it'll be 4
1,000?
thousandths, right? You with me? Not a big thing. That's just what it is. And how do I write 1,000 again? 10 to the 3rd, right? And I want it to look like this. So what I'm going to do is I'm going to force those up. Are they going to be happy when I force them up? No, they like it where they are. So when I force them up, now I'm going to catch up to somebody out there. So negative power means you're actually dividing by that many tens, which is why it becomes a small freaking number. Oh, yeah. Again, some of you guys are probably sitting there like, I know all this shit. Some of you guys are like, oh, okay. All right. Now, one more thing, and then I'm going to shut up and let you guys do a few problems out of the book. Oh, let's try to do this. So here again, look, how many times do you have to move the decimal? So there's one digit in front of it. 1, 2, 3. That's why it's a 3. It's negative because it's small.
Is it 15?
Say again.
15?
15?
Because there's 15 zeros.
Oh, up
So
here. Okay. I'm with you. All right. I'm sorry. Yeah. So this will be 3, 6, 9, 12, 15. Kick ass. 4 times 10 to the 15. I love it. Catch up to you first. All right. So let me erase this. How you guys feeling? I mean, that's a little review. Okay. That's really why we created that notation, so we didn't have to write so many freaking zeros. Okay. One more thing I want to do. I'm going to let you guys try some problems out. How could I use scientific notation to help me multiply this out? Oh my God. How do you write this in scientific notation? Three, 9. Yeah, so 3.2. Do you see how the decimal has a single digit in front of it? So I'm going to say something really strange. Scientific notation, okay, it's really strange. We'll share it with you. I think of it as a 10 vampire. It sucks all the freaking 10s out of something. So if I stopped here, isn't that 32? Doesn't that have 10s in it? So it's got to suck them all out, right? God, that's strange. 3.2 times 10 to the, I forgot. 369. Is that cool?
Yeah.
We suck 9 10s out of this thing.
Wait, sorry. How did you get
Sorry?
9 and not 8?
Say again.
How did you get 9 and not how'd you get 9 and not 8?
So what is our goal? I want to move it until there's one digit in front of the decimal place. So I need to stop right there. So
Oh,
there's
okay.
just a 3 in front. How many times do I move it? 3, 6, 9.
Okay.
I want all the 10s to be right there. Because if you look at this number, the most important part of this number is right there. Because if there was a star that was 10 to the 8th light years away, and there's another star that's 10 to the 2nd light years away, I don't even care what the first part is. I know one of them is a freaking hell of a lot closer to us, right? Okay. So that's that part. What's this going to be?
Three times 10 to the negative 5?
Good. It's 5 places, but it's small, so it's negative. Ass. Now, a little side note. Let me do this in, yeah. What does this look like? Oh, God. Okay. I got all the wrong things. All right. Side note. What is 4y squared times 2y cubed, for example? You probably can't see that online, can you? I got one marker that works. Damn it. 4y squared times 2y cubed. How do you do that?
You add the y's.
Okay, so you get y to the 5th,
No, 4 times 2.
4 times 2, 8, right? No big deal. You multiply the numbers, you multiply the letters. Because that's all you can do. What the hell is 4 times y? Blue, right? All right. So here, same idea, right? I've got nice numbers. What's 3.2 times 3? 3 times 3 is
6.
9. 0.2 times 3 is 6. And then what do I do with the powers? Add them. So I have 9/10 minus 5/10 is 4. Done. Maybe. Okay. It kind of makes sense because this is so big, but this is so small. So this kind of eats some of this, right? There's another way to say that. It dilutes some of this. It divides some of this. It gets, All right, now, so I want you guys and you guys, if you look at your book, I think I finally got these numbered. I would very much like you to do. Yeah, okay. Page 2. Just do those 4 real quick. On page 2, you'll see 4 problems there on page 2. You guys see that? You can do those 4 problems very quickly for me. And then page 3, I want you to do these problems. So page 2, let's see. Page 2, 1 through 4. Page 3, I want you to do, doesn't really matter. 1, 2, and 1, 2, 3, I think. 1, 2, 3. Sure. Oh. I guess I didn't take it. By the way, guys, just to remind you, the very last page of this thing is the answers to all the stuff. Maybe don't look at that yet. Trying to forgive that. Well, I've moved into the wrong territory. This is true. But, I'm not disappointed this season. Break records and milestones and still lose. Oh, well, I'm sure your disappointment probably doesn't even come close to his. No. But yeah, just speak up if you guys need any help online or in the room. Everybody online, did you guys get the links, the link to the sign-in sheet and the little booklet that we're using? Did everybody get those?
Yeah.
Quick question.
Yes.
So is it on page 2, is it the 1.2, the rules of exponents? The ones that we're supposed to do?
Oh, it says 1.4 exercise problems, so the actual problems.
1.4, okay.
Do you see them? 1.4 exercise problems? It says 31,536,000 is the first problem.
Sorry, could you repeat that again?
It's page 2,
Yes.
and it's 1.4 exercise problems, so towards the bottom. And the first problem is 31,536,000.
I can't see it for some, oh no, sorry, I see it.
Okay.
Yeah, I got it.
So somebody didn't get the link. Let me repost those. Here is the sign-in sheet. Here is the workbook kind of thing. Bam. If you're connecting with your phone, good luck to you. I'm sorry. It's just, hopefully you can access what you need.
Professor, I have a question.
Yes.
I'm so sorry. I'm actually on my lunch at work right now, and I have a question regarding it's I saw in the workbook it's actually the 3rd unit. I wanted
Yeah.
to know if I could ask you the question really quick and then head back to work.
What you got?
So I'm struggling on like on the equations where it's saying how many grams are in 451 kilograms, and my all of my work is right. It's just my answers are wrong. And I
Okay.
don't know, and it's moving the decimal point over that I'm finding that
Yeah.
I'm messing up at.
So what we're gonna talk about is, you got kilograms. And then you got something that very few people know about is hectograms, decagrams, grams, decigrams, centigrams, milligrams.
Mhm.
And every step here is a step of 10. The metric system is based on 10,
Yeah,
which is why it makes all the sense in the world. So if you had like 1.7 kilograms and you want to know how many grams that is, 1, 2, 3. 1, 2, 3, 1,700. Just every step you have to take, that's how many times you move the decimal in that direction. It's silly. So if I want to go from decigrams to hectograms, I would move the decimal back. 1, 2, 3.
and that would
That helps.
cause that,
No?
and that would be a negative? Because we're
Well,
moving
yeah,
that way.
so if I had like 89,000 grams, and I want to know how many hectograms that is. Well, from grams. So this would be 1, 2. So I just moved the decimal 1, 2. So that'd be 890.
Okay,
Yeah. So it really is just the same as our system, except our system is insane. Our system is absolutely insane. 4 quarts make a gallon, and 2 cups makes a pint. You know, it's holy crap. So they just said, why don't we just use 10? Because their number system is based on 10. Okay. Let me
Thank
come
you.
back. Yeah, you're welcome. How's this going? You guys can check your work as you go?
Yeah.
Yeah, go ahead. Yeah, feel free. I love you guys being so honest out there. Not a test or something. Let me know if you got a different answer, if you have a question about why the answer is different. The thing that gets people tripped up is when there's a bunch of numbers that aren't 0, you don't care. You just move that decimal until there's 1 digit in front of the decimal. Neato. Oh, did I do, this is funny. Let me see if I did 4.2. Yeah, I think I did Sig Figs. Of course I did. But yeah, it's 2.12 times 2 is 4.24. And that would round to 4.2. Yeah. You don't have to worry about Sig Figs yet, but I think I did that just in case you looked at it later. I wanted to flow with the Sig Figs. But right now it's just, you know, it should round to be the same thing. Yeah. You guys good out there? Okay. I'm gonna take that as a yes. Okay. Anything about, yeah. Number 2. Yeah, okay, this is a good one. All right, that's the one I was waiting to see. So here's the big question. Is your answer in scientific notation? What was it, times 10 to the second and third? So I agree with you. It's 36 times 10 to the 5th, right? But doesn't it say, write your final answer in scientific notation? Why is that not scientific notation? The decimal's in the wrong place, right? Yeah. So now watch this. I love this. I really want you guys to be with me on this. That wants the decimal to go which direction? Make it bigger or small? Let me say that. Bigger. Make it bigger, right? So it wants it to move 5 places that way. You with me? We need the decimal to go back 1. Right, so I look at this guy and see he's got work to do. It's like, I gotta move the damn thing 5 times. And we come in and we go, now how many times does he have to move it? You can do it. From this place, it was 5 times. Now he's got to move it 6 times. Now, let me give you a different way to think about it. Let me give you, what's funny is I like this method, but let me show you the more mathematical way to think of this, right? Take 36 times 10 to the 5th Write the times 10 to the fifth, right? What is this in scientific notation? Ten to the first, right? Put your tens together, what do you get? Same answer, right? So if you have an answer that's not in scientific notation and you need it to be, you can actually just kind of think about it, or take the part that's not in scientific notation and then just combine your tens. Right? That's it. Okay. And again, a lot of what we talk about today, it might not come up directly in your classes. It might not come in your class at all. Depends on what class you're in, but it could. How did all the other ones go? You guys good? You guys all understand? You can check your answers. The very last page is all the answers. Did all the other ones come out okay? Everybody good? I'm going to take your word for it. Yep. Let's see. So 3 was the, what's it, 1 million? 1 million times, what was it? 023, 023? Or is it 0023? 0023. I just put some extra zeros just for Sig Figs. I don't know. So if I write this in scientific notation, that's 1 times 10 to the 6. This will be 1, 2, 3, 2.3 times 10 to the negative 3. So I get 2.3 times 10 to the third.
But it doesn't matter if that, because in here it has 2 zeros actually.
Yeah.
And again, for us right now, we haven't talked about Sig Figs. I think I did that so that when you come back again and look at it again, it does match with Sig Figs. Yeah. All right. So I'm sorry at the moment. We don't have to worry about Sig Figs at the moment. The future you will appreciate that. Here you go. Sign in real quick, and then there's a little pamphlet we're using. Yeah. All right, everything else good? Yeah. All right, you can try the other problems out on your own. You've got the answers in the back. It was requested of me. I think I teach math, but grammar is fantastic. To add a little something about percentages, and percentages get me really sad because in the world today, we're presented with so many percentages and people just do not understand them. And then they make all these decisions based off the misunderstanding of percentages. For example, the natural gas price. I don't know if any of you guys are worried. Did you have a high SDGE bill last month? Okay, so natural gas price, let's say just for the sake of argument, it rose by 300%. And then it reduced by 68%. So people were saying, oh, that's still a 232% increase. Completely wrong. Totally wrong. I think it comes out to be a 28% increase. So here's what, if I double something, isn't that a 100% increase? If I cut it in half, doesn't it become the same number it was? So take 3, double it. What is that? That's a 100% increase. Now take 6 and cut it in half. 3, does it come right back to where it was? So a 100% increase followed by a 50% decrease, same number. People don't think the fact that the percentage doesn't mean shit by itself. It's a percentage of something. The 100% was of 3. The 50% was of 6. Bigger number, yes? That's what people don't think about. They just look at the percentages. And unfortunately, there are people out there that take advantage. They know what people don't understand. So like, yeah, that's great. You know, it's like, holy shit, just calm down. Just learn a little math. Okay. But I'm not coming down on you guys because percentages just, I don't think they're really explained well or something and not really taught well. So I have a really quick little blurb there. If I want to know the percentage of left-handers, how many guys, anybody left-handed? I'm not going to raise my hand because I don't mean to point you. I'm sorry. Is anybody else left-handed? Okay. So if I wanted the percentage of left-handed people in this room, I would do the number that matches what I'm looking for, 1, divided by the total. That's how you do any percentage, right? You guys, with me? That's it. Percentages are part divided by whole, right? Some of you guys might remember is over of. If you don't, that's fine, because actually I hate that, but it's part divided by whole. That's all a percentage is. Okay. I'm not going to say too much more about that because it's just a little brief add-on that I did. Let's get into what should be everybody's favorite. How many of you guys have talked anything about significant figures? Anybody? Okay. All right. How many of you guys have heard significant figures, even if you haven't talked about it? All right. Okay. How many rules do you have? Those of you who worked with them to tell how many sig figs something has. All right. I'm gonna take it down to 2. You like that? You don't like that? You don't want to?
No,
You can
I'm
keep
fine
your,
with
okay.
that.
So a lot of times I hear people saying, well, this 0 means something. This 0 doesn't. All right, complete bullshit. I'm sorry, science people. I keep pleading with you, but I don't know why you don't. So first off, I really want you to understand, why do they exist? So mathematically, let's say I have team A. They go to the Arctic and they take an ice sample and they measure something and they get 0.03, right? They measure 0.03 whatevers. Team B goes down to the Arctic and they have more money and they have the flashiest bullshit. So they measure 0.030. Mathematically, math looks at that and says, what? It's the same freaking number. Those are both the same stupid number, yes?
Yes.
Science says, all right, math, we got reasons for this shit. So I don't want to have to write a paragraph. I can just very quickly, which team is representing more confidence in what they've measured? You guys agree? B, they dared to go out another place. So this is sort of like they're saying it's somewhere between 025 and 035. You guys, these people are saying it's somewhere between 0295 and 0305. Isn't this much tighter? They dared to go out the next place. I really want this to make sense. So science, and again, math people, science people, we don't butt heads all the time. We do butt heads on a few things, but this is kick ass. I mean, we're like, that's cool, whatever. It's a really quick way to communicate to somebody. I've done all these calculations and I don't want to write up a whole paragraph on how confident I am. Bam. You guys semi with me? So
That helps so much.
Good.
I was wondering, why is that 0 matter?
that's where you should start. So when I teach math, I always try to start with, why did we even come up with this word? Why do we even need this process? Why do we even do this shit, right? That I try to start there. And this is one of those things that if you don't have the foundation of why the hell do we give a shit about it, right? This is why. It's a very quick way to communicate a lot to somebody. Now, the actual measurement. I know, I've seen it. I've seen like 5 or something rules from people. Here's the trick. Not a trick, but if I have a number that has a decimal explicitly in it, and let me make sure you guys understand. Is there a decimal in that number explicitly? No. But where's the decimal? Okay, after the 7. But there isn't a decimal in this number, right? You with me? So that's what I mean. I always get somebody who's like, every number. No. So if it's a number that is a true decimal, you start counting at the first non-zero number and you count all the way to the end. So what's the first non-zero number?
3.
Let's start counting. 1. I'm in. All right, so it's Sig Figs 1. What's the first non-zero number? 3. Count to the end. 1, 2. Sig Figs equals 2. That captures the idea that they are more confident. That doesn't really translate into they're twice as confident. It's not like that, but they are more confident. That's what it's trying to show people. Okay. You guys with me so far? So just the basic step of how many sig figs does this have? Because the next step you guys know is what happens when you multiply and add and shit, right? If you've done any sig figs. And those of you that haven't, this could be in your future. So pay a little attention. But I don't know. Depends on what class you're in. So if there's a decimal number, you find the first non-zero number and you count all the way to the end. Yes? That's rule 1. I think it's in the packet, right? Rule 2 is if it's a whole number, right? There's no decimal explicitly in it. You start at the first non-zero and you end at the last non-zero. So let's see what happens here. 1, 2, 3, 4, 5. 5 Sig Figs. Make sure you guys. And why does it make sense? Because I was just talking about metric system, right? Sig Figs should not care which units I use. If I suddenly go from centimeters to millimeters, am I going to be more confident about what I measure? No, I'm going to have the same level of confidence about what I measured, right? It's just going to move the decimal place. So what if this was, you got it, Jeff, millimeters? What would this be in decimeters? I would move the decimal once, twice back, once, twice back. So it'd be 18,502, right? So those zeros are what your teachers are calling insignificant, maybe, or what do they call those zeros? Not whatever. I can't remember what they call them because it doesn't matter. You don't have to think of it that way anymore, right? So it's just if a change of units would actually make the zeros go away, then you don't count them. So like here, if I change my units and move the decimal over, doesn't that zero go away? So of course I'm not going to count it. Now, do you actually have to take that into account when you're counting it? No. If it's a decimal, first non-zero to the end. If it's a whole number, first non-zero until the last non-zero, like bookends, right? I guess feeling. All right, so I want to do a couple more examples. I want to show you the one place this sort of breaks down. There's one place this isn't fair. And I'll show you what people do to make it fair. So what if I had, I don't know what it is with me in 18.130000. How many Sig Figs? Does it have a decimal? 8. Right? If it has a decimal, you start at the first non-zero and you go to the end. 1, 2, 3, 4, 5, 6, 7, 8. Because if somebody else said this, aren't they not as sure as these people? Okay, so again, there's a decimal, you count to the end. If there isn't, you stop at the last non-zero. And I challenge you to see, does it match up with the rules you were given? Yes. You'll get the exact same answer both ways. So why do it the way with 4 or 5 rules? Again, that's fine. You guys can keep, if any science people are watching, you do what you need to. What about this here? 2. So this has got 8. Are you guys good out there? What'd you say? Or somebody just went, oh, okay. 2 Sig Figs, yes? It's a whole number. Start at the first non-zero, end at the last non-zero. What if I just do this? Or not even that, just this. Yeah. Yes, 1, 2, 3, 4, 5, 6, 7. All of a sudden it shoots up to 7.
If there's a decimal, you count all the way.
All the way.
But if there's just like a number, you stop where the numbers are.
Stop at the last non-zero. So here. Start at the 7, stop at the 4. That's why it's only 2. Right? So you stop at the last non-zero. I really want that to make sense because it just simplifies everything. Hopefully. And if you like the other rules better, and you can use them, whatever makes more sense, right? How are you guys feeling out there? So let me show you the one place this is not fair. What if we go out and we measure something? We measure the shit out of this thing, right? And we get 3,000. We just get 3,000. We're like, that's what it is. It's not 2,999. 0.7846. It's not 3,000.735. Then it's freaking 3,000. Are you with me? How many Sig Figs does that have? It's not fair. Yeah, what the shit? So what do? You change it to scientific notation. What would scientific notation be? And what you do is you bring the zeros. 10 to the third. How many? So what's this? 1, 2, 3, 4. That's fair. That's a whole other reason we use scientific notation. Yes, maybe. That situation does not happen very often. There's very few things in the real world you measure and it comes out to a perfect whole number, right? Doesn't happen a ton of times, but it happens enough. Yes, am I with me? Right? So if I change this to scientific notation and I can stop here. Okay, I'm now communicating. It's still the same number. I'm just not as sure. I'm even less sure now. I barely know anything, right? Do you guys see what I'm saying? So changing the scientific notation helps you designate how far out your actual confidence goes. How are we doing so far? Okay. How am I doing on time? Not. Well, what is today? Oh, I got till 4, right? Yeah. I think, right? Don't have till, yes, I do. So let me say the rules one more time. It's got a decimal, start at the first non-zero, count all the way. So the thing with decimals, you count all the way. Doesn't have a decimal explicitly in it, it's a whole number. Start at the first non-zero, end at the last non-zero. So if it's a whole number, you don't necessarily go all the way. That's the difference. Okay. All right. So what happens? Oh, let's do this real quick. Let's do this. Just to make sure everybody's with me so far. Page 5 at the top of the page. Right? Page 5 at the top of the page. Just do those 6 problems really quickly for me before we move on. You guys all see that? Starts with 12.5. Maybe we could make this a little bit better. Whoa. Maybe that's better. That's a little freaky. Okay. That might be better. Oh. And she'll need one of these. Oh, you got one. Okay. I think somebody just come in online. I think so. Let me put 2 things for you in here. Will this work? That didn't work, I don't think. Shoot. Hold on. Oops, somebody just left. It might have been the person that just came. Just in case. I will put these 2 things in there. Again, just you guys online, just speak up or chat away if you have questions. So this is a you get it or you don't moment, right? If you got it, you're done. If you didn't get it. Oh, number 6. Okay. Number 6. Oh, I think this didn't print out correctly. It is supposed to be 6. Hold on. Let me see. I've got the one online here. I think that, yeah, I think it got freaked out. Do you see how it's not in alignment? There's supposed to be more numbers there, but the way it's written, what is it actually? 3. But I think it didn't print out the whole thing for some reason. Where's it at? There you are. Yeah, it's supposed to have more things there. But
That's not a good question.
so number 6 should be 3 sig figs. I think it just didn't print the whole thing out. I'm sorry, did I miss? What's up?
Are we doing the 2.2 exercise
2.2,
problem?
Yeah, 2.2, right at the
Okay.
top of the page. So you
And
guys
then
can,
for the, I had a question. You said for page 3 is 1 through 3, but what exercise problem is it?
oh, the only exercises that were on there. 1.6.
Okay.
Yeah, okay.
Got it. Thank you.
So, okay, so I'm pretty sure everybody's done it and checked, right? Let me, guys, online, can you see this? Can anyone not see that online? Can you see that?
Yeah, we can see it.
You can see it, okay. I was trying to make it better, okay. So number 1 is, of course, 3 Sig Figs, because it's a decimal, so you count to the end. Number 2, it's a decimal, count to the end. 4, because number 1 and number 2 are like team A and team B. Team B is more confident. Number 3, still 4, right? Just move the decimal back, so those zeros don't mean anything. It's just a different unit of measurement, possibly. Number 4, so a whole number, so I stop at the 5, so it's got 3 Sig Figs. Number 5, good. Whole number, you stop at the 5 again, so that's 4 Sig Figs. And then the number 6, the the weird one, it's supposed to be 3 Sig Figs. I gotta check that. I don't know why that did that. Okay. All right, so here's where things get here's where things get weird. So the reason we have certain rules for when we multiply and divide Sig Figs is we want the information about how confident we are to propagate and come out in the end. So if I had 0.071 times, let's just say 50 and 11. How many Sig Figs does the first guy have?
2,
2. How many Sig Figs does this guy have?
1.
Good. So my answer will have the weakest link. Who's the weak link here?
The 1.
The 1 Sig Fig. So my answer is gonna have 1 Sig Fig. I don't worry about that yet. That's the last thing I do. The Sig Figs that I can figure out from the beginning, I use it to round my answer at the end. So can somebody just do that? What's 0.071 times 50? So the actual answer is 3.55, right?
Yeah, so
It needs to have 1 Sig Fig. Yes. In fact, look what I can do. Start counting. 1. Okay, so I want to round to this place then. 4. So that is still communicating to whoever sees this answer, this is how sure I am. If I say 3.55, I'm like representing some shit. We really don't, right? Maybe. Okay. So watch what happens if I do this. 0.07100 times 50. Right? It's still 3.55, correct? But now how many Sig Figs? How many Sig Figs is here? 4. 1. So this is still going to be 4, right? So if I wanted to have the answer be something other than 4, I need to increase the weakest guy, right? So let's say it was, let's see, let's kind of organize this, Jeff, for once. Yeah. Okay. So let's say it's 0.071 times 50.0. So now this has got 2. This has got 3. So then I still get 3.55. My answer has to have 3 Sig Figs. It does. So I leave it alone. So the last thing you worry about is how many Sig Figs the answer is supposed to have. That you're going to use it to round.
Where does it have that?
I'm sorry, 2. It's
Okay.
gotta be the weakest guy. I was gonna do this thing next. All right, so it's gotta have 2 sig figs. Thank you. So it's always gotta be the weaker dude. So then what would I have to do to this to have a 2? I'd count 1, 2. So then that would be 3.6. Okay, thank you. Okay. So multiplying and dividing are the same thing. What rules the day is who's got the least sig figs? The weakest link. I don't know if you guys ever, you guys know about that game show from a while back? Okay. So nothing too bad about that. Let me show you one example that gets people really tripped up though. Let's try 18,000 times, yeah, let's do 1 point. Let's just do, let me think. Yeah, let's just do times 11, sure. So just first tell me what that is. What's 18,000 times 11? 180,000, so it would actually be 198,000, right? Because you get 10 and then another one of these. How many sig figs does this guy have? 2. How many sig figs does this guy have? 2. 2. So you answer's gotta have 2 sig figs. So here's the mistake I get. 1, 2. So I gotta round it to this place. And somebody tells me, there you go, Jeff. Does that look good? They're saying 198,000 is roughly 20. Right? How many people are coming? 20 people. You have enough chairs? No, gonna be short a few chairs, right? Do you understand the mistake though? They just focus so much on the fact that they have to stop here that they forget it still has to be this number rounded, right? So here's what really gets trippy. I picked a really evil one. So if I do bring in these, does that capture 2 sig figs? How many sig figs does this have? It's got 1 sig fig, right? So how do I, you guys know how to improve that? Yeah, well, 3, 4, 5. I want 2 sig figs, right? Done. You guys see that? I didn't even mean to make it that evil, but it's a little more evil than I thought it would be. You can always go back to scientific notation if it turns out it's not accurately representing the sig figs, right? So the main thing to realize there is your answer rounded better be close to the actual answer. That's like it. Okay. So what about, so that's multiplication division. They both work the same way. The number of sig figs rules the day. What about adding, subtracting? So let me ask you to do something you haven't done. I'm going to ask you to do something mathematically that you haven't done in a long time. Can you just really quickly, by hand, add these 2 things? It's been a while, right? Okay. You're all like, Jeff, they invented these things. Oh, yes. Sounds about right. So just tell me, what is it you guys are doing to appropriately set this up? Decimal places. Decimal places rule everything when I'm adding, subtracting. Real quick, do you know why? Yes, you can only combine like terms. So I can only put the ones to the ones and the tenths to the tenths and the hundredths to the hundredths and so forth. If you're missing somebody, you just give them something. And of course, we have to be careful because we know how many sig figs are here, right? But in this case, it's not the number of sig figs, it's the decimal place. So which one of these has the least decimal places? Which one of them has how many decimal places does this guy have? 2, right? What about this guy? 3. You guys with me? So your answer is gonna have the least of those. So if you add these, you do get 3 0 carry the one, yeah, 13.003, is that right? So you better have 2 decimal places. So you went around to this place. So what will it be? Done. So when you multiply, divide, the Sig Figs, the weakest Sig Figs, when you add or subtract, it's the weakest number of decimal places.
Say that again.
So when you multiply or divide, it's the number of Sig Figs. Whichever one is the weakest, the lowest Sig Figs, that's going to be what I base my answer on. When I add or subtract, decimal places rule everything. So it's whoever has the least decimal places. That's what tells me how to set up the answer.
By decimal places.
This has 1, 2 decimal places,
Oh, okay.
right? This has 1, 2, 3. Right? Okay, I thank you for saying that because I noticed that when I asked that question, it was like, I don't know.
Yeah.
Said something. Okay. So watch this. What about 10 plus 0.8714? So first, just what is that? What's 10 plus 0.8714? Who's got the least decimal places? This one has how many decimal places? 0. None. It's got 4, doesn't matter. So mine better have no decimal places. So I want to round to this whole number. So what would it be? 11. Because again, it's communicating to somebody that this could be 9.5 to 10.5. I don't know. So the answer's got to communicate, hey, there's part of this thing that I'm not really that sure about. Some of you guys look at me like you're angry now. How much has your teacher teach you about multiplication, division, addition, subtraction yet? Or you just been focusing on telling how many Sig Figs?
We've been working through it, yeah.
Okay. So multiplying, dividing, least Sig Figs rules the day. Adding, subtracting, just the same way it was when you first learned it, decimals rule the day. The weakest link in terms of decimals, right? All right. Nobody else see a peep from online, so I'm thinking you guys are okay. So do this for me. This is the big one. We're not going to do all these problems. At the bottom of that page 5, do number 1, 4. Let's see, 1, 4, 6. And 8. Try those. Oh yeah. Sorry, bud. Did you get the signage sheet? No. Either you're stealthy or just not. So everything we did today, the answers in the back of the booklet, right? So later, if you want to go through it, kind of try some of those out.
Is it the 2.3 and 2.4 exercise problems?
That's right. The one that's at the bottom of page 5.
Okay, yeah.
2, 3, and 2, 4. Yeah. No, maybe I went a little crazy on the correction for this. Let me see. Is that still okay? Whoa. Wait. Whee! Sorry. So again, hopefully you guys have some kind of calculator with you. I normally bring some, I just didn't bring them. Just throw all these in the calculator. The important work is for the humans. We have to know what to do with things. Calculator just doesn't know shit, it just does the addition. Which problem? Sorry, just saw, oh, okay, you got it? 1, 4, 6, and 8. Yeah. And again, if you want to, you could try another one out. Check it in the back.
I feel a lot better now.
Oh, good, all right. Oh. Did I miss something? Oh, I see. Everybody out there okay? Okay. Yay, I got a thumbs up. Yay. Man, this takes me back to the days when I only knew people as a black box with a white name. I thought the first day I was gonna come back, I was gonna put like this costume where I just have this cardboard over me, all painted black with just my name on it. I am Jeff Waller. Because I went slowly insane for a while. As we all did. Are these coming out okay? I mean, so you just throw them in the old calculator. And the real work you have to do is determining what to do with the answer. So number one, the operations are all addition. So what's going to rule the day there? Number decimal. Who's got the least decimal places on number one? No, that has two.
2.64.
Yeah, 1126.4 only has one decimal place. So you just throw in the calculator, get the whole big freaking answer. What do you guys do when you just put it in the calculator? What is, before you do anything to it, what do you get? Wait, 11,000? Wait, what? Oh, 1147. I'm sorry. I thought you said 11 point something. Okay. 061. Okay. Is that what you guys got?
Yes.
Okay. Now you round it to one decimal place. So 1147.1. Did I get that right? I don't trust me anymore. Oh, no, Jeff. I did. All right. Sweet. All right. What about number 4? It's still subtraction and addition. Who's got the least decimal places? 125 is a whole number, right? So let's see, what do you get? 128.879? Is that right? Just making it up as I go. And like we said, so I really want you to understand, you don't have to worry about the sig figs or the decimal until the end. You just put all that stuff in. Yes?
I didn't know what they're up to.
Oh, so again, number 4, what's the only operations? Yes, what are the operations in number 4? Are they multiplication? Is there any addition, subtraction? When you have addition, subtraction, it's the decimal places that rule the day. So 125 has the least. I need this to have no decimal places. So I want to round to the whole number. So 129. Gas. Cool. Add, subtract, least decimal places. Multiply, divide, least sig figs. They both accomplish the same thing. Real quick, by the way, real quick, I just want to show you. If you do 1.0 plus 0.2, 1.2, right? That's pretty sure. If you used multiplication division rules, doesn't this have one sig fig? Doesn't this have one sig fig? So your answer better have one sig fig. That wouldn't make any sense. 1 plus 0.2 is 1. Add another 0.2, it's 1. Add another 0.2, it's 1. You're like, shit, I'm keep putting shit in here. Right? I just want to make sure you understand. I forgot to show this to you earlier, but why is the rule different for the different operations? Because of what makes sense. That's why. And then finally, or not finally, but next, number 6 is some division. So what rules the day there? Yeah, so the top has how many sig figs? 4. Bottom has 5. So answer better have 4. We just divide it. What do you get? Big ass thing. What do you get? Is it how big is that?
160.
Whoa, start.
116.22.
Nita. And now I gotta round it to have 4 sig figs, right? 1, 2, 3, 4. That's exactly how you do it. So we're gonna round it to this place. So 116.2. Cool. Did you get that one right? I want to tear. All right. Dude. Yeah, stop. All right. Well, maybe you can. Actually, you can. It's not better. All right. So number 8. What's number 8? There it is. Oh yeah, this one freaks people out a little bit. 3.3 cubed. So what's the what is exponents? What are they based on? What are exponents based on? Exponents are based on multiplication, right? How would you do 5 cubed? 5 times 5 times 5. So this is multiplication. So what rules the day? Sig figs. So it's 3.3 times itself. So they all have 2 sig figs. So what's the answer without doing anything to it?
35.93.
And now that's going to have 2 sig figs. 1, 2, 36. Big ass. Okay, not too bad, right? Okay. All right. Here comes, if there's anyone have any questions about that? And again, there's more problems you can do on your own if you want to later and check the answer in the back. And hope it might even be right.
Yeah, quick thing. I have to leave soon. What problems do we work on?
Oh, no, you can do all of them because all the answers are on the back. The last page is all the answers. So now that you've got this thing, you can just work on whatever you want to and check the answer.
Okay.
Yeah.
All right, thank you.
So the next thing is one thing that people ask about. You're like, when are we going to get to freaking ask about that? So conversions. First thing, I sort of talked about it really quickly when that person was asking earlier that had to leave. So unfortunately, I gave away part of what I try to get out of people, but there's kilo. So you can do the beautiful thing about metric. It's based on 10 because their number system is based on 10. I don't know why it's based on, I have no idea why it's based on 10, right? If you think about it, if we didn't have pinkies, our number system would be based on 8. We would go 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. Let's not think about it too much. Okay, so our number system is based on 10. Metric system is based on 10. And everybody pretty much knows kilo, right? You know, kilometers, or you watch too many crime things, you know, kilo for a certain amount of cocaine, whatever kilos, whatever kilograms. So you have kilogram, you can have kiloliter, and you can have kilometer, right? Or kilometer. Then normally people don't know the next two. And then of course they definitely know gram, liter, meter. Anybody notice what I put up here earlier? Or does anyone know what it is?
King
Yeah, there you go. Somebody knows the saying. It's the
King
first time
Henry
ever.
died drinking chocolate milk.
King Henry, hectogram, hectoliter, hectometer, died, deca, so this is deca, this is hecto. King Henry died Monday, laughing, giggling, right? So whatever you want. King Henry died, Monday, laughing, giggling. Drinking, so this is Deci. Chocolate, this is Centi. Milk, this is Millie. You guys probably can't see all that online, I'm sorry. That's just too bad. No, I mean, let me see what I can do. King Henry died Monday, or one of these. Drinking chocolate milk. Drinking chocolate. Why did I put M's up there? Dadgummit. Milk. Okay. Milliliter, millimeter, milligram, all that kind of stuff. Okay. The one place that we use metric in the States, does anyone know? There's two places actually that we use metric. How do you buy Pepsi? Liters.
Oh, shit.
Anybody use any tools? Do you have like hex nuts? It's
Yeah, we have like when you're doing sockets and stuff.
sockets.
We have it's is it millimeters or something?
Yes, or they have the like 5/16 inch, or they have
Yeah,
9
the
millimeters.
wrenches and stuff, the
Yeah.
5/16.
That's the two places that we sort of run into metric here in the States. We are the one country left on the earth. There used to be 3, and the other 2 have decided to join everybody else with metric. We're the one country left on the face of the earth that does not use metric. Go, USA. Okay, sorry. Oh my God. So your science professors probably are crying to themselves about this thing. So how does this work with conversions? I'm going to erase this so I could just kind of like get it together a little bit better. And I don't know if you guys were working earlier, so you might not have noticed this. King Henry died Monday, drinking chocolate milk. Every step, this doesn't have to be Monday, it could be Tuesday. Every step is a step of 10 because their number system is based on 10. So if I have 10,962 decimeters, now be careful about deci and deca. Do you see how like decimeter versus decameter? How do I remember that? Damn, that's big. So that one's bigger. Damn, that's 100 times bigger than this guy. You guys see that? Once, twice. Okay. So if I want to go from decimeters to hectometers, all I got to do, 1, 2, 3. 1, 2, 3. Done. Now, real quick, can anybody show me how long an inch is? Just give me an idea how long an inch is. Anybody can do that? How long is an inch? Yeah, sure. What about this one? All right. Anybody tell me how long a decimeter is? Anybody show me how long it is? And of course, you know, that's the immediate thing most Americans think when there's anything about changing the metric. They're like, I don't know. You would if we taught metrics. Of course you would. You just would know it the same way we know inches and shit. And life would be better. I'll stop. Okay. Do you guys get this? This is almost too nice to believe. So if I had like, I don't know, 0.0062 kilometers, and I want to know, let's make it kilograms just to be different. I want to know how many centigrams that is. So now you know why there's a mnemonic device, because if you're going to write this down, you could just count, right? So how many places do I have to go? 1, 2, 3, 4, 5. 1. You see I'm going the way that I'm going? It's oh my God. 2, 3, 4, 5. So I need to add a 0 on. Crazy. Okay. So that's how metric works. And then you try to do shit between the two of them, metric and our weird ass thing, right? Real quick. Well, that's sort of an urban legend, but there's some proof to it, possibly, that our number system is based, our measurement system is based on measurements of the King of England. Like our foot is basically how long the king's foot was, and that's because back in the day, kings were given by God. So of course, everything about the king was like, oh shit. So they're like, that shall be the unit of measurements. How long your foot is. So our foot would have been, if we had somebody with stilted little tiny feet, we would have had, here's a foot. Anyway, sorry. All right. So, I think what you guys are really, really waiting for. So can anyone tell me, does anyone know 1 inch is how many centimeters? Does anyone know? 2.54, kick ass. Now watch this. So if I had 760 centimeters, how do I make that into inches?
Centimeters on the bottom.
Yes, so let me show you this cool thing. This actually runs into this dimensional analysis. So one-step dudes like this are pretty straightforward. It's really all about do I divide or multiply. But if you have trouble remembering, watch this. What unit do I not want there anymore? I want to replace it with inches, right? Where would I put centimeters so it would cancel? On the bottom. Cancels. What number goes where? Well, we just said 2.54 centimeters is 1 inch. Divide. This is on the bottom, right? You guys see that? Dude. Can you do it for me? Nice.
You can do it.
299.2.
How am I getting this weird? So what is it again, sorry?
299.
212, blah, blah, blah.
Yeah.
All right, Sig Figs time. As your teacher said something about conversion numbers have infinite sig figs. 1 foot is defined to be 12 inches. There aren't 2 sig figs in 12. There isn't 1 sig fig in 1 foot. A conversion number has infinite sig figs. So basically you don't think about the conversion numbers. Even 2.54, which honestly is not the real numbers, it's rounded. We still take it as a conversion number. It's got infinite sig figs. What matters is our measurement. Somebody measured 760 centimeters. So what's got to be true about my answer? Because what operation is this? Division. So what about this guy rules the day? Sig Figs. How many Sig Figs has he got? 2. I don't see a decimal, right? So I need this to go 1, 2. How does this keep happening? I totally made this shit up. All right. So this is this, right? What would this be? 300? Why is that not fair? That's 1 sig fig, so I would do this. Okay. That's crazy how often this happened today. You guys understand what just happened? So I've got to round it to this place. That's a 9, so it's got to go up here. 1 sig fig, oh shit, there. Now we're communicating. It's the same number mathematically, but it's communicating the science correctly. Okay, I like it. It's so weird how that happens. Just all right. So weird. Yes, I should play the lottery. Yes.
On page 7, can you go over 2, 3, 4?
Oh yeah, we're getting there. Don't worry. Okay. Oh shit, I got so little time. So this, let me do this. All right, let's see. All right. 12 inches in a foot, right? 1 point, yeah, there 1 point. 2.54 centimeters in an inch, yes. How many feet in a mile? Anybody know? Say it.
5,200.
There you go. I love it. So if I wanted to know, if I have 98,000 centimeters, and I want to know how many miles that is. Now we're talking. Right? This is the kind of problem. The mistake people make is they don't take a second to figure out their path. What do I mean by path? Where can I go? From centimeters, I can go to what? Inches. And from inches, I can go to what? Feet. From feet, I can go to miles. There we go. That's the path. That's the path I could take. So I'm going to start with centimeters. I follow what I've just done. I want to kill centimeters, go to inches. I'm not even gonna put the numbers in yet. I want to kill inches, go to feet, right? Kill inches, go to feet. And then I want to kill feet, go to miles. All right, now I can go back. Now see, that's dimensional analysis. You're making sure all the dimensions kind of work out the right way, so you end up in the right place. You don't get freaky ass centimeter miles. What the hell are those? You got stuff like foot pounds. That's an actual measurement. Yes.
What was number 3? 'Cause the other- yeah, it's not a position.
Well, that's all right. But so that's got its own thing. You gotta be careful about with moving the decimals. That's the point with that one. So we'll do that one in a minute. So now I can put the numbers in. 1 inch is 2.54 centimeters. 1 foot is 12 inches, and 1 mile is 5,280 feet. So what do? So I'm in the calculator. You're gonna put 98,000 divided by 2.54 divided by 12 divided by 5280. If it's on the bottom, you divide. So on the top, you multiply. Almost too nice to believe. So it's just on you to know which things you have to memorize, right? Now, if you're in chemistry, you're dealing with moles and milligrams and Avogadro's number and holy crap. And if you're in astronomy or physics, you're dealing with newtons to whatever, right? You got your own units to worry about. I almost don't care what the answer is. What's got to be true about the answer? Which one of these is not a conversion number? This, that's an actual measurement. Everything is a conversion. So the answer's got to have 2 seconds. Right. Basically out of time, which is bad because I got to go for office hours. But number 3, real quick. If I have, what did it say? 9.1 times 10 to the negative 31 kilograms, and I want to go to milligrams. So King Henry died Monday, big AG, drinking chocolate milk. So I want to go 1, 2, 3, 4, 5, 6 that way, right? Now listen, wouldn't this be this decimal moved back 31 times?
Yeah.
If I move it forward 6 times, now how far back would it be? I really want this to make sense. Right now it's 31 places that way. We're going to move it forward 6. No, we're moving it forward 6, right? Forward 6.
25.
25. So this would be that many milligrams. This tells you which direction you're going. So you should be making the answer bigger from kilo to milli, not micro. Obviously, you guys, depending on you have stuff up here and you have stuff down there, depending on which thing you're taking. You might have picoliters and nanometers and micrometers, depending on your class, right? And the last couple things real quick. I'm sorry, I didn't really do my time well. There's a little bit of an algebra review. There's not much there, to be honest. It's mostly messing with variables, right? If I say PIV nert, does anyone know PIV nert? The ideal gas law, not there yet. Okay, sorry. So it's just a big bunch of variables that you have to play with. And then the last thing is just about how to make a good graph. The thing about graphs is you don't make your scale. Like I always have students that are like 11, 12, 38, 39. Straight line. Holy what? So it's got to be consistent, right? You got to label stuff. You should be making a decent number of graphs in your courses, so you have to know labels. You have to have a nice consistent scale, right? How did I get? Okay, so I'm sorry I got a little fast at the end. So you got these packets, and feel free to come into the Math Study Center with any math related stuff you're doing. We help people with chemistry, physics, and CBTE.
You guys have to-
Have what?
have,
I'm only doing one more of these, and it's actually geared towards trigonometry and vectors. It's the higher level of math for science students. I'm not doing another one of these. I am going to post this. I have people in the Mass Study Center that can help with physics, help with chemistry. Some can help with chemistry, but especially if it's the math that has you down, we could definitely, everybody can help with that. Yeah. Thank you. Yeah. Yeah. You guys online? You guys good? Everybody signed in online? You guys can head out if you want to.
Thank you. They couldn't come, so.
Oh, I'm sorry. She was good? She was good? Okay.
One more actually?
Yeah.
Thank you.
Sure. Oh, thank you.
Thanks. Really
Oh, yeah. Good to see you again, Raleigh. Thanks, guys. All right, how do I do this again? You're welcome. See you guys.